Good morning, everyone. I'm glad you're here. I hope you are enjoying your weekend. Today is Sunday, May 22nd, 2022. And there was an earthquake close to the Snake River Plateau, a magnitude 3.0 according to USGS. But I actually got a larger magnitude. A magnitude 3.48. It could have been as large as a magnitude 4. Kind of hard to tell with the seismic signature. Let me bring it over here. You can see it brought up a lot of magma in the system. We'll go over here and I'll show you the signature. I went by the magma because it was a really long tremor, lasted a long time. Let me bring it over. So it seemed to have settled down close to this time zone, and the seismic signature, let me show you that. It was actually hard to tell where it stopped because it rumbled for so long. Look at that. And this is an earthquake that was caused by the movement of tectonic plates. And as you know, a lot of activity, volcanoes, are along areas where the continents collide. And we'll go to where it began. Let me pull it over here. I'll show you the monitor that I used to get this signature. Alright, here's the location of the 3.0. We got Kellogg, Thomas Falls. Here's the station. It was fairly close. Over here we got Newport. You notice the area drawn out in blue. Eons ago, this was a glacial lake area. And once the ice age started to end about 12,000 years ago, there was a wall of ice that held in all the water that was in this location, and it collapsed. And yeah, it all flooded out, going all the way towards the west coast of the United States. Let's see. The orange line is the partial trench fault. Now, back in 2015, there was an earthquake swarm near Sand Point. You can see the notes that I got there. The partial trench fault runs about 185 miles through North Idaho and into British Columbia. This is also an area where the landmass is slowly rotating clockwise. And the researchers feel that the compression from the clockwise rotation stops, and this is where the Earth's crust is slowly being squeezed together. The compression from the clockwise rotation may have reactivated the partial trench fault. So anyways, that's not far from there. I have noticed lately, let's pull this out, speaking of tectonic movement, there has been earthquakes going from, let's say the northwest area, sliding southeast. Yeah, there's been quite a few. Here we have the last 30 days of earthquakes of a magnitude 2.5 or greater. This is the most recent. This here is the largest. That was the magnitude 4.2. Back on the 11th of this month. That was close to the Sour Creek Resurgent Dome. All earthquakes within the last 30 days. This is all that USGS does report. And see the line there that I was talking about? The triangles, those are quarry blasts. Being the weekend, USGS doesn't report all the earthquakes. Neither does the University of Montana or the University of Utah. This one here, it says it was put in by USGS. They're saying it was a 3.0, but it was actually larger. I just refreshed the page. They're saying it was an intensity level of 3, which means it would be felt noticeably by people that were indoors. But they often would not recognize it as an earthquake. Maybe you thought it was a truck going by or something else. Standing automobiles would have been rocking slightly. And like I said, vibration like a passing truck. Another thing I want to mention about this earthquake and other earthquakes in this area, it very well could be glacial rebound. That's where the earth is slowly rising back up after being pushed down by compression from the last ice age. Now, for those of you that are interested in that magnitude 4.2 earthquake that occurred on the 11th, looks like USGS changed the location a little bit farther west. And I'm going to show you something here. We'll bring it out. Okay, there's the 4.0. Over here on the bottom right, that's Sunlight Volcano. We got Parker Peak. This is all within the uplift of Yellowstone. And then to the left, a little bit farther, this is the area that Bob Smith of the University of Utah feels the next eruption might be. You notice it's not far from the Sour Creek Resurgent Dome. That's another area of uplift. And it's not far, let's see, from Black Dragon Caldera, or Cauldron, right there. This is an area when I was doing some research, found trees that had died from the sulfur coming up. But another thing that a lot of people probably don't know when they're watching the live webcam, when you're watching the steam for the different geysers, sometimes it changes color to gray like smoke, or black like a coal fire, black as coal. That is caused by iron sulfide, the rock heating up, burning up, and rising up with the steam. Here at Black Dragon's Cauldron, the water there is often black, and that's how it got its name, Black Dragon's Cauldron. And the area is slowly dying off because the hydrogen sulfide rising within the spring, and iron sulfide. Iron sulfides are responsible for the black color of the cauldron. So the same thing happens at these geysers. Smith Ferry there in Idaho had 2 earthquakes, the largest being a 2.8, a 2.0. Down here is the Snake River Plateau. And then on the 20th, there was a 1.8, Stanley, Idaho, and a 2.0, same location, a 2.4. There was quite a few earthquakes there on the 20th. A 2.2. Let me show you that location. These were all along the Trans-Challis fault system. I haven't done an earthquake report since my, a couple days ago. Things have not changed. Yeah, still having earthquakes. I've been watching it daily. Nothing different. So unless we have large earthquakes, yeah, I'm not going to cover the same old. Yeah, Yellowstone is recharging. And then over here we got the Sawtooth Fault Zone. Yeah, this is the, let me zoom in a little bit closer. You can see the exact location of that earthquake. There you go. Now that one was a magnitude 2.4. And we'll bring it back out. And that's the Sawtooth Fault Zone. And in 2020, that's when they had the 6.5 in this location. And we'll come back out and go down. And there's the Snake River Plateau. Those of you that have followed me over the years will know about the more recent lava flows. We got craters of the moon, which was about 10,000 years ago. Shoshone lava field. Now that was about 12,000 years ago. And we got Hell's Half Acre. There's been about 40 small eruptions since the last major eruption. The black line was from 2015, the extent of the uplift from Yellowstone. And then, yeah, I still haven't gotten a chance to update the caldera rim because it's actually extending farther as the magma comes into the system, more of a northeasterly direction, all the way up to this area where that 4.2 was happening. All right, so recent earthquakes. On the left here, that is the borehole for the Madison River area. This is the monitor close to the recent almost 4.0 earthquake here in the center. And this is Little West Thumb, and there's got what, 1, 2, 3, 4 marked in red. And let's go to that one at 11:06. Now it shows up both on the borehole at Madison River, right there on the left, and this is Little West Thumb. Little West Thumb, the computer figured it was close to that location. That's why it's marked in red. This other one, that's just too far away. It wouldn't pick it up. But it's got a better signature at Little West Thumb. And let me pull it down. It comes in as a magnitude 1.90. All right, that's it right there. And its signature. And then there's another one they're not reporting. Let me make that bigger. All right, right there at 11:13. Now this is universal time. It starts out as tectonic, the movement of the tectonic plates. And then it moved into volcanic, which means it brought up magma. And like I said before, when you have an area where plates collide, in this case there's a rift system nearby, yeah, you'll often see volcanic eruptions. And that one comes in as a magnitude 1.92, not quite a 2. You can see I brought up magma and it just went on for a little bit. And then we got, let's see, what else? This one up here at 6:56 universal time. That one comes in as a magnitude 1.59. It's got a nice signature on it. Yeah, quick popping of the rock, which went on again. Same thing. This one was volcanic that went into harmonic. Yeah. So the location of these earthquakes was somewhere in this area. This here is Little West Thumb. There's areas here where there was a lot of hydrothermal eruptions over here. Yeah, they actually call it West Thumb Caldera. This area erupted and formed somewhere between 162 to 150,000 years ago. Yeah, and doing some research over the weekend. Yeah, they got Duck Lake Formation, which was a hydrothermal eruption that was between 4,000 and 6,000 years ago, they figured. And then more recently, they discovered this area close to Duck Lake, another hydrothermal. And it's quite large, and it's got steep walls. It's 500 meters wide. So that would be about 1,640 feet around, or across, I should say. And it's surrounded by walls, steep walls, where it blew out. Some areas are 12 and other areas are 20 meters high. So 20 meters is about 66 feet, and it's got a flat bottom, which means it's been filled in with sediment. And there's other, what they call nested craters within the same area. more hydrothermal eruption areas, some as deep as 40 meters, which would be about 131 feet deep, meaning, at least to me, that they would be newer, more recent hydrothermal eruptions. When you have an explosion with water meeting the hot magma, yeah, it can flash and explode and throw out rocks and, all kinds of debris. And the temperature down there is about 160 degrees Fahrenheit or 70 degrees Celsius. That's some hot water. There is also flows of rhyolite. It's got a cap of rhyolite right now that's preventing from dike intrusion of more lava. It's called magma when it's under the soil. But the rhyolite in this area is less than 10,000 years in age. So in this location is where the Little West Thumb monitor is at. They did put in a new one over here when the borehole went down. Let's zoom in. Let's see, this image is actually from 2015. So it's somewhere over here. You can see all the dead trees. And let's come out to where that crack's at. Okay, West Thumb caldera. Right through here. Now, evidently, this canyon, where it's trying to come up, the magma, is anywhere. I found two different documents, 430 feet to 390 feet deep. And the temperature down there at this canyon is 340 to 350 degrees Fahrenheit. And yeah, there's another. I found out about this other hydrothermal explosion that happened about 8,000 years ago. That was after Mary's Bay explosion. They call that Elliott's crater. But if using Google Earth, if you look, you can see different points where there were probably other hydrothermal eruptions just by the discoloration. And let's bring it out. There's other areas. Indian Pond was created by a hydrothermal eruption. Over here we got the fishing bridge. This area is slowly rising up, kind of choking off the water going out through the Yellowstone River there. And this is also an area. Last document I could find, at one time there was almost 10 inches of uplift in this area. So there's at least 3 earthquakes for Little West Thumb that have been recorded by the computer. There's been smaller ones. You see one there. And another one there. See how it's round? That's another indication that it's the plate's moving. Okay, yeah, sharp popping there. This is what it was showing when I pulled the files, about an hour or so ago. This here is what they call the blobs of magma coming into the system. And then we got some in red up over here, if I can find it. Let me go to the signature. Let's see, where is it? I don't know. It looks like probably right in there somewhere. Anyways, the only other one I can find in red would be these two here. It's got 2 marked in red. Let's make that bigger. Again, this is the monitor that's close to that 3 point whatever. Actually, it was closer to a 4.0. And we'll look at its signature. Yeah, tectonic again in movement, and we'll bring it over. See, we had, yeah, look at that. 1940 to 1941. Did they report either of those? No, they did not. See, we got, let me pull this over. We got that 3.0, which actually was larger. A 1.8, that was at 1545. Yeah, nothing at 1940. I really shortened up the seismic signature. Normally when they have two so close together, what USGS would do is put them as one, and it comes in as a magnitude 3.3, but they did not report it. Surprise, huh? I find all this geology really interesting. So that's all I have for you. I hope you enjoyed it as much as I do doing the research. If you have any additional thoughts or comments, yeah, put those down below. Thank you for subscribing. Thank you for your questions. Have a good weekend, and I'll talk to you later. God bless you. Bye.